Hello and welcome back. So today we are going to take a look at the Cartesian coordinate system and the beginnings of graphing linear equations. So the first step to this is of course going to be remembering how we find points on the line and also defining the slope. So in the equation y equals mx plus b, m is our slope, and that is what we are going to concentrate on for today. Before we get into talking specifically about slope, I wanted to take a minute just to refresh things. All our coordinates are listed as a x-coordinate and a y-coordinate. Our x-coordinate is let me get my pen modifier so I can draw nice lines. Our x is going to be on this blue line right here. And it shows us our left and right, or how far we are from the origin, which is 0, 0, located right here in the middle, 0, 0. And then our y-coordinate is going to tell us how far away from 0, 0 we are going vertically. So we have a x, y. So let's look at a couple examples of what this might be. So if we looked at point O here, we would look x first. So how far away from 0 am I to the left? And I can draw a line, and I see I am at -7 away from 0 there. And then vertically, I am 6 away from 0 here. So O would be located at -7, 6. However, let's say S. I can draw my lines. Boom. So I know that S, as far as the X goes, is 2 away from 0. But now it is -8 away from 0 vertically. So it's very important that we know the difference between our x and our y. X is our horizontal distance away from 0. Y is our vertical distance away from 0. This is going to be very important here in just a minute. But now we were talking about m. So if I was saying the equation of a line is y equals mx plus b, and we've already decided that x and y are a point on the line, then I'm going to say this is true where m equals the slope. More specifically, slope is going to be the steepness of a line. And now we'll see it represented a couple different ways in mathematics. A lot of math things say rise over run. I'm a big airplane type of guy, and I did a lot of walking in the Air Force. So what I say is walk under fly. And it doesn't sound as nice as rise over run, but it makes more sense to me. And the perhaps easiest way to find slope is if you have a graph, you can actually just count it out. When you're looking at the graphs, look for the points. So you can see it's really hard to see, but there is actually a big square point on the ends of these here and here. And what that does is that tells us specifically that this line snaps to that point. It may come close to other points, but it absolutely hits that point. So I can actually find a point x, y there. Now, I could find the points and do some math that way, but there's a much easier way. When we read a book, we read a book from left to right, or from left to right. When you read a graph, I want you to be in the same perception of reading from the left to the right. So our first point we look at is going to be this. Our second point we look at is going to be this. And what you want to do is you want to take and draw a horizontal line from the first point. So we have our first point. I'm going to draw a horizontal line all the way across. The next thing I want to do is I want to draw a vertical line from my second point. Come out to my second point. There's my vertical line. Now, just like a pirate, where they meet makes an X. An X marks the spot. So now I'm going to go on ahead and annotate that. I want to find how far does it take me to walk to that X. So I am going to count each grid line in between here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grid lines. I had to walk 10 steps to get to that intersection. 10 will be my number on the bottom. That is how far I walked. Now I want to find out how far I have to fly to my next point. So to go up, 1, 2, 3, and 4. I had to fly 4 steps up. Now, always remember with the slope, a mixed number is okay. Fraction is okay, but we want to reduce it. Always simplify your answers where you can. We know these are both even numbers, so I can divide by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Now, because it's 2/5, that means I could have found a point in here other than that. If I walk 5, I should be able to go up 2. So let's try that. If I walk 5, 1, 2, 3, 4, 5. Now I should be able to go up 2 and be on the same line. 1, 2. And look, we are on the same line. And that goes back to similar figures, ratios, and a whole bunch of other concepts. But it's important to know a linear equation is a line, and therefore all of the individual slopes across it is the same as the overall slope. It's part of the definition of what the line does. So let's look at this next example. We have our first point, and we are reading from left to right. Our second point. With our first point, we want to make a horizontal line. So I'm going to draw a horizontal line that intersects that point. With our second point, I want to draw a vertical line that intersects that point. And where they meet, X marks the spot. I want to know how far it takes me to walk to this point. So I'm going to count all of my grid lines. 1, 2, 3. And that's my walk. Took me 3 spots to walk there. Now I want to find out how far it takes me to fly. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But now I didn't actually fly up. I flew down. And when you go down, what kind of a number is down? Down is a negative number. So my slope in this case is negative 10 over 3. And if you ever wanted to actually look at it to be able to see whether or not it was a positive slope or a negative slope, I happen to like Mr. Slope Guy. And I might be doing a video on him later. But he has one eye with a plus, and it looks like the eyebrow there. A minus, which is negative slope, and an eyebrow there. And you'll see that both of these eyebrows kind of match what these slopes look like. It's a good reminder. Now, there is a thing in math where you could potentially have a vertical, but that is actually undefined. So we make his nose look like that. And if you ever had a slope that was absolutely flat, it would be a slope of 0. And so you have Mr. Slope Guy. If you're in my class, he's in your notes, and we've already talked about him. If you want to learn more about him, leave a comment and let me know that. I might actually do kind of play around with slope on Desmos like I did in class and introduce you to Mr. Slope Guy. So that's finding it with a linear equation, or a graphed out equation, which is super simple. Let's see if we can make this for the not so simple times. Sometimes you don't actually have a graph, you only have numbers to go with. Kind of like when we're using an in and out table, um, that would be the times we would need to do this. So to do this, we need to go back to slope, and we know that walk over fly. Well, a good way to find distance, if I needed to know how far I was walking somewhere and how far I had traveled, I would take my distance and subtract where I started from. Or if I wanted to know how far up or down I traveled, I'd want to take my distance and subtract where I started from. And that's exactly what we're going to do. So the equation for this is going to be fly over walk is going to be the same thing as y1 minus y2 over x1 minus x, oops, x2. And just so that we understand what's going on, xy is how we define these, x comma y. And because our Cartesian coordinates will always be xy, we do have 2 points. So this is point 1, this is point 2. And each one of them has a x and a y. So I have x, y, and x, y. And what those actually are is going to be the subsets. So this 1 here refers to my first point. The 2's here refer to my second point. So now all I have to do is substitute the information I know. I come down to my first point, y1. What is the y value of my first point? Well, that is -4. And then I look back at my formula and it says I need to subtract. So I'm going to subtract. And now I'm going to put y2, or the y value from my second point, which would be +5. Looking at my formula, that's going to be over how far I walked, which will be x1. So I find the first x value, 4. And I'm going to subtract x2, which is my second x value, 5. So now I have something that's just arithmetic. Integers can be a little bit of a pain. If you're having problems with integers, please practice integers. Let me know if that's something you need help with. But we're going to go with the fact that you know this. So we're going to start at -4, subtract 5. Because I'm starting at -4 and subtracting 5, I'm going to get more negative. So that means I actually add them and keep the same sign. So it would be a -9 over 4 minus 5. 5's a bigger number, so that means I'm going to cross 0. So that would be -1. Well, I know that -9 divided by -1 would be, well, 1 goes into 9 times. And a negative divided by a negative is going to be a positive. So that means in this case, my slope is 9. Easy peasy. Let's try it one more time just to make sure we clarify. I have 1 point and my second point. So I want to know, what is the y value for y1, my first point. The y value is right here, -1. So I'm going to take -1. I'm going to subtract that from my second y value, -2. And I'm going to place this over the x value from my first point, -5, and subtract that from the x value of my second point. Positive 5. All right, now I just have to remember to keep my integers straight. Now I have subtracting a negative number. If you remember back with integers, subtracting a negative number is the same thing as adding a positive number. So I like to go on ahead and change those as soon as I see it to help me keep things straight. Now, -1 plus 2. So if I owe John $1 and I pay him $2, that means I am up $1 over -5 minus 5. If I owed the bank $5, but I borrowed another $5, that means I'm going to owe them another $10, so -10. And this is simplified. So in this case, the slope would be 1 over -10. Now this is a positive slope, so I would ask you, with Mr. Slope Guy, you could potentially see that, oh look, positive slope, that's going to be that type of a I. And this is a negative slope, so that means this slope is going to be going down and to the right. A lot of cool things you can do with lines. They enable us to make predictions and approximations, and we can use them in the real world a lot. In fact, as an aircraft mechanic, I can't tell you how many charts I looked at, especially voltage charts that linked with temperatures to tell me how hot, how cold something was, what the pressure was, how much quantity was in it. I remember checking coolant temperatures, one thing, and we had to know the outside temperature, the voltage kicking out of the computer, and a couple other things, and we put them all on graphs, and it would tell us whether or not it was a good range or we needed to add more liquid. Cool stuff. You'll use this in the real world in some form or fashion. In fact, most of the time, I bet people use it and don't even realize they're doing it. Hopefully this helped. If not, leave a comment. Let me know what you want to learn or what I'm leaving out. Let me know where you're struggling. That way we can make things better. Regardless, don't forget to click like, subscribe, hit the little notification bell. I'll see you in class tomorrow.